Good day, ladies and gentlemen. This is Sarel van Grennen, aka Mr. VG. And man, it's gonna be an awesome day today. Today we are specifically going to dig into one of the most amazing chapters in mathematics. And I kind of want to say it's the one chapter that everything builds up to. We are going to use almost all the chapters that you have done in your school career. We are going to use in functions and graphs. Now, this first video is specifically about my little bit of advice to you as a grade 11 learner, maybe your grade 12 learner. Remember, if you are a grade 12 learner, there's also a series of videos on functions and graphs which incorporate inverse functions as well. Grade 11 learners, ladies and gents, you don't have to know what inverses or inverse functions are for you to enjoy this series in the grade 11 junior Tukkies summer school. So what we are going to work with specifically today is I want to give some of my advice to you about how to study graphs better. Because in my opinion, and it's not just my opinion, you guys have been brought up mostly thinking that maths is not a study subject. Well, I really want to debunk that myth and say maths is the subject with the most amount of studying. Because at this moment, I can ask you anything from grade 1 up to grade 11. And anything you've done before grade 11 is just considered basis or foundational knowledge. So you have to really fill that mathematical toolbox of yours. And you have to make sure that you have your theory down. So what I'm going to share with you guys today is a way of studying graphs better. Now, a few years ago, I've been, hashing and running around and wondering how can I make mathematical summaries more, intuitive for myself. So what I did was a few years ago, I developed a one-pager on how to summarize basically any topic. But this specific way works specifically with graphs. It works perfectly. So you can have all your knowledge per graph on one page. So let's have a look at what I did. Now, my summary page that I developed looks like this. In the middle, you've got the title. Moving outside of that, you've got definitions. In other words, what makes something what it is. Axioms. Most of you, if you haven't watched my mathematical reasoning, you might not be very familiar with axioms, but those are things we accept to be true, which are things like, for instance, the interior angles of a triangle adding up to 180 degrees. Things like the adjacent angles on a straight line adding up to 180 degrees. We haven't really proven that, but we accept it. Outside of definitions and axioms, we've got theorems, formulas, and properties. Now, those are the things you guys should focus on a lot. Not all you should focus on, but you mustn't forget about those. And then on the left of the screen, you'll see there are special techniques. On the right of the screen, you'll see there are methods. So what I'm going to do is I want to dig into parabolas and make a summary of this. So on one page, you can see everything you need to know about parabolas. So let's dig in. If I look first of all, that I have to always remember to work from inside out. Please don't just focus on the outside. Start inside out. So when I look at parabolas, my inside is, of course, that I'm working with parabolas. What is the definition of a parabola? Well, that's the standard form, y equal to ax squared plus bx plus c, with the highest power of 2. or the degree of the polynomial being 2. But there's also a second form, y equal to a bracket x minus b squared plus q, also a highest power of 2 if I multiply out the brackets. Now, what theorems and formulas and properties do I have? Well, first of all, if a is positive, it's smiling, and if a is negative, it's frowning. Next up, I can get the turning point from the normal turning point formula, x equal to negative b over 2a. Now, incidentally, that's also the axis of symmetry. So that is also just something you might need to remember because we can ask it in the exam. So the axis of symmetry. Always the x value of your turning point. Now to get the y value, we simply substitute that x value back. Now if I've got the other form, the turning point formula, I can simply read off my turning point. And my turning point is positive p and q. So in other words, whatever the p value was in the bracket, so if it was x minus 1 squared, then the turning point would be at positive 1. Always remember, it's always with the x value that we swap around the signs. What other properties do I have of a parabola? Well, let's first of all look at roots. Now, where will I have roots? Now, if you think back about nature of the roots that we did in the previous series, if you haven't watched it, please go back and watch it. But with roots, it's when I have y equal to 0. Now, if I have y equal to 0 in the ax squared plus bx plus c form, then I can get delta to be b squared minus 4ac. But what does that tell me of my parabola? Well, if delta is larger than 0, I've got two x-intercepts. That is awesome to remember. Now, it doesn't mean that the graph is necessarily going to be smiling. It could as well be frowning. But it's just about the number of x-intercepts. If delta is equal to 0, I've got one x-intercept, which means the graph turns on the x-axis. If delta is smaller than 0, there's no x-intercept. Again, it could be a frowning parabola. We don't know. But let's quickly have a look now at moving outside two methods. Now remember that you've got to be able to convert between ax squared plus bx plus c to the turning point formula. And how do you do that? Now, most of you might think, I remember something about completing the square. Maybe my teacher showed me. I'm just going to tell you, please, don't stress about completing the square in form 4 or grade 11. But in grade 12, when you look at circles in analytical geometry, you do need to be able to complete the square. But then how do I do it without completing the square? Well, simple. I just get the turning point, because that's going to be P and Q in the turning point formula. Now, I also have to go back up, and that I simply do by multiplying out. Now, ladies and gents, something nice when you actually do your summaries is have a few examples, especially if there's a topic that you are struggling with. Like I took going from the standard formula ax squared plus bx plus c into the turning point formula as an example. So let's look at an example of taking y equal to negative x squared minus 4x plus 5 into the turning point formula. So what I do is I determine the turning point, x equal to negative b over 2a, which means the graph turns at x equal to negative 2. Perfect, there's the p value. To get the q value, I substitute back, and I have an answer of y equal to 9. Fantastic, that is the q value. So all I'm going to do now is I'm going to substitute what I've got into the turning point formula. So now I have that a is negative 1 because that's what's in front of the x squared. The p value is negative 2 and the q value is 9. In other words, my formula is negative x plus 2 squared in brackets plus 9. Well, there I've got an example. Now, a special technique that we've got to remember is that one of the important things in parabolas is that you have to be able to determine the equation of the parabola. Now, the equation of the parabola depends on what has been given to you. Now, usually, I'm either going to be given the x-intercepts. If they give me the x-intercepts, I've got to remember this formula. Y equal to a x minus x1, x minus x2, where x1 and x2 are my x-intercepts. Or they give me the turning point. If they give me the turning point, I go to the turning point formula, where P and Q are my two turning points. Now I want to challenge you as I finish off this specific video that you must go and make summaries of all of the functions, straight lines, exponentials, as well as hyperbolas. Make your summaries as best as you can. Make sure that you've got things like axis of symmetry, the form. Make sure that you have things like special cases, maybe. Those kind of things. It's not that you will necessarily lose marks, but they could ask it. And then it's usually 2 or 3 marks that you throw down the drain. So yes, it can actually cost you marks. But more importantly, it helps you to understand what you are doing and helps you just that little bit to make sure that you do not make silly mistakes. So this is Mr. VG, and I am excited to be on this journey with you. Please remember to hit that subscribe button, to hit the notification button so you receive new videos directly on your feed. We are going to be looking at a number of things in this series. We are going to look at parabolas and exam questions about them. We are going to look at exponents. We are going to look at hyperbolas and how I expect them to ask it in the exams. We are also going to have one video about a few weird questions. Remember, if you are struggling, if you are not getting this right, ask a teacher, ask your tutor, but don't just try and try. And when you don't get it right, give up. Come and ask us, and we will gladly assist you. Have an absolutely beautiful rest of your day. Cheers.